Well, now we practiced slope of parallel and perpendicular lines. We can use that slope to write equations of those lines. So goal number 5 for section 1.5, we're writing equations. And I'm going to start with point slope form again. Writing equation of lines parallel and perpendicular to a given line through a point. So each example, you will write 2 different equations. One's going to be perpendicular, one's going to be parallel. This is very similar to your week 2 problem. So after watching this, I want you to go and try week 2 problems, okay? Writing equations of lines parallel and perpendicular to a given line through a point. Consider the line y equals negative 6x plus 5. Look, this is in slope-intercept form. Because this is already in y equals mx plus b form, we can tell that the slope is negative 6. Okay? So, slope of the original line is negative 6. So to be parallel to this, take a look down here on part B. In part B, we're going to write an equation of a line that is parallel to this line. So the slope that we have to use for part B should be the same as the slope of the original line. So down in part B, I'm going to use negative 6. Okay, they have to be the same. But what about for perpendicular? Okay, what about for perpendicular line? Okay, it should have an opposite reciprocal slope, right? So instead of negative, it's going to be positive. But if you write negative 6 as a fraction, that is negative 6 over 1. The reciprocal will be, if you flip it, that's going to be 1 over 6, right? So the slope of an equation, slope of the line that is perpendicular to the original line should be 1 over 6. We reviewed this opposite reciprocal slope in the previous about 3 different videos. So hopefully by now we are comfortable writing these or identifying these perpendicular or parallel slopes. So let's start with that. I have a slope, but I need a point to write in point slope form. So did they give us a point? Let's see. It says, find the equation of the line that is perpendicular to this line and passes through the point. Of course, they gave us the point. That is perfect. So what they gave us is x of 1. The x coordinate is negative 3. And the y coordinate is negative 6. So if I do the point slope form, which is y minus y1 equals m times x minus x1, the equation will be y plus 6 equals 1 over 6 times x plus 3. I will distribute this so that I can write this in slope-intercept form, okay? That will be y plus 6 equals 1 over 6x plus 1/6 times 3 is going to be 3 over 6, which reduced to half. So the y-intercept of this, well, I'm sorry, it's not the y-intercept just yet, right? Because y is not by itself yet, it's y plus 6. So I have to subtract 6 from both sides. That's going to give me y equals 1 over 6x, and I have to do half minus 6. If I do half minus 6, I'll get half minus 12 over 2, and that is negative 11 over 2. Negative 11 over 2 is the y-intercept. So I did the fraction work by hand today, but if you're using your scientific calculator, that's also okay. I'm going to circle this, and I'm going to show you how I can check this answer, okay? So what I think I just found is an equation for a line that is perpendicular to the original line. So what I will do is I will go to my graphing calculator. I'll open a graphing calculator, and I will type the original equation in there. The original equation was y equals negative 6x plus 5, right? my answer, the one that I just got by all that work, is y equals 1 over 6x minus 11 over 2. Okay? Let me just visually check if these two lines look perpendicular. First condition. Where is the green line? All right, let me try to zoom. Oh, they're down there, sorry. So for me, you know what? They intersect, and if I hold a piece of paper at the corner right here, I think, yes, they look perpendicular. I'm literally holding a piece of paper, putting a corner in this intersection. This does look perpendicular, so that's good. Now, the second condition is, remember they said my equation needs to pass through a point -3, -6, right? So let me plot that, okay? If I do plot a point at -3, -6, and try to label this, it's my green answer, my green line, gonna go through that circle. Let me take a look. Where is it keep going? Oh, here it is. Look at that, how perfect. My answer is not only perpendicular to the original line, but it's also passing through the point -3, -6. So I know that I got my answer right. All right, let me keep on going to the second one, okay? The second part is asking you to find the equation of a line that is parallel, but the points are the same. I think we're using the same point. So the x of 1 is -3, y of 1 is -6. Let me do my point slope form then. Point slope form. You guys probably know by now that I really like this form. Y minus y1 equals x minus x1. If I plug in all my numbers in here, that will be y plus 6 equals -6 times x plus 3. Distribute the -6. This turns into y plus 6 equals -6x minus 18. Let us subtract 6 from both sides. Oh, the y-intercept will be very low. It turns into y equals -6x minus 24. So I'm going to circle this, but you know, I'm not sure if this is correct, so I will check this. Because I always like to check my algebraic work using graph. So down here, I'll just go ahead and say y equals -6x minus 24, and they graph this line in black. And I was comparing this to the red line. Red is the original line. Definitely, these two lines look perpendicular. Can you see that the red line and the black line are parallel to each other, right? And not only that, my black line, my line that I just graphed, the -6x minus 24, is going through -3, -6. So that is perfect. So I suggest you do that because, you know, always check your answer, especially when you're on your third one on your ALEKS homework. So that is it for this example. I do have the second example of this kind, but starting point is a little different. So please watch that second video too, okay?